Hi, folks. So I just completed the first part of my research about the smart structures. And the bottom line is that we have this vibrating structure with a certain period of vibration and frequency. And our electromagnetic force is going to be able to counterbalance the earthquake induced forces. So the first phase was complete, and I already produced the first document, the first research paper successfully. The first part's result was in form of equation. I named the equation inertial reduction equation in function of time. You can see that's a fancy, very fancy name, but it's the proper name for the equation. Um, Turns out that the some of the metals has a great um, some metals has a function called permeability, which is the capacity of the material, a property of the material to transmit, to be able to transmit the electromagnetic force. So uh, we are going to use steel, which has a high permeability of 100, and also we are going to induce current to the system. So we created an electromagnetic frame as a part of the research in order to demonstrate the behavior of the electromagnetic frame against the behavior of a classic frame. So once the earthquake strikes the structure, uh, the electromagnetic field is activated, and the initial current is induced into the system, uh, going very fast through the capacitors. The capacitors are surrounding the columns, and uh, in doing so, the magnetic polarization between the columns and beams and the floor will be opposite, will be activated, and will be equal but with different directions of action. So the bottom line is that the column and the floor will be separated by this electromagnetic field, by the force, the electromagnetic force, and pretty much the floor will be levitating while the column underneath moves with the earthquake force. Uh, the beam will be stay above of the vibrating column because of the electromagnetic force, and then during all the earthquake duration period, which is around 10 to 30 seconds. So in doing so, all the floor and all the elements on top of the floor will be safe, including the people, which is the most important part of our research, because it's about to protect people, protect their assets. Uh, so the results very good. So the equation, the inertial reduction that we expect to obtain during a high energy earthquake, which a high energy releasing event, is in the range of 20 to 30%. We are not expecting to reduce the whole mass of the floor or the slab system, although it's possible theoretically. We are not expecting to do. So we are doing in some practical way, reducing the floor mass inertia in the range of 20 or 30%. So in doing so, we can reduce the earthquake forces as much as 50%. So during the 30 seconds of the duration of the event. So the mass reduction or the inertial reduction equation is directly proportional to uh, the permeability of the material, as I said before, also to the initial current induced into the system, uh, and also is inversely proportional to the pseudo acceleration, which is pretty much the pseudo acceleration factor of the earthquake produced by the earthquake. And I created this fancy constant. I call it a kind of gamma species constant, which is pretty much the topology tensor of the equation because contains the number p, also contains the current and direction of current flow in the capacitors, uh, and also contains the modal generalized mass constant and the modal shapes of vibration. So that game special or fancy game constants, if you like it, is the constants that will determine the topology of the system. The bottom line is what that means is that the topology is going to be the force arrangement between the electromagnetic field and the dynamic and static force of the classic system. So in the next phase, the second part, I will to complete the research by generating the new uh, design spectrums for the designed seismic for the design earthquake, uh, considering the electromagnetic mass reduction. So, as you are aware, uh, we use those design spectrums to design earthquake resistant buildings, and those design spectrums are correlated with the capacity of ductility, of resilience and ductility of the um, buildings, which is expressed by the C coefficient of the damping coefficients. So most of the time, we engineers used to use the design spectrum with a damping coefficient of 5%, which is pretty much enough for a conventional concrete reinforced structure. But now I'm going to incorporate the electromagnetic effect, which is going to make the design spectrum a little bit lower in the axis, since it's going to affect the pseudo acceleration component of the design spectrum. So so far so good, and I will try to, as well, from the management point of view, to get some resources, to raise some funds in several rounds, to get resources to prove my theory on the lab, on the structural lab, build up a scale model to have fun and to uh, make some progress before going to the patent process. So until next time, folks.